Okay, so let's solve this problem. A 25 kilowatt 240 volt DC shunt generator has armature and field resistances of 0.06 ohm and 100 ohm respectively. So determine the total armature power developed when the machine is working as a generator with a 25 kilowatt output and as a motor taking 25 kilowatt input. Right? So first things first, we would of course know what would be the diagram of the shunt generator, right? Now, so let's have our first question as a generator. So as a generator, generator. Okay, so diagram. Of course, you have our EG, positive, negative, and then you have our RE, and then we have our RSH, and then we have our VT. Okay, for our terminal voltage. Now, from here we have a 25 kilowatt, right? So this, if we would take this as a generator, this will be our output. Okay, so we'll have our IL, and then of course we have our ISH, and then our generator will supply the load IA. Okay, so from here I will create my load. So from here, the next thing to do is to solve for the armature power. So the armature power acting as a generator, so we all know that our armature power PA is just equal to EG multiplied by IA. Okay, so from here, first things first is to know what is EG and then our IA, right? But what is our IG and IA, EG and IA? So in order to solve for IA, so solving for IA, we need to take KCL at this node A. So KCL at node A will have IA minus ISH minus IL equals 0. So IA will be equal to ISH plus IL. But what is our ISH? Our ISH is of course equal to VT, because they are in parallel, divided by my RSH. Okay, why? Because VSH is of course equal to our VT. Now, it is given the problem that is a 25 kilowatt 250 volts, so therefore our VT is equal to 250 volts. So in this case, my ISH will be equal to 250 divided by our RSH, which is equal to 100 ohm. So therefore this is equal to 2.5 ampere. Next is our IL. So we have our PL, or the power of the load, or the power that can be supplied, or the maximum power that, or the full load power that the generator can supply, is equal to 25 kilowatt. So therefore we can solve for our IL multiplied by our VL, which is equal to 25 kilowatt, right? So from here I will have a value equal to my IL multiplied by VL, which is equal to 250, which is equal to 25 times 10 raised to 3. So therefore our IL will be equal to 25 times 10 raised to 3 all over 250, which is equal to 25 times 10 raised to 3 divided by 250. So 25 times 10 raised to 3 divided by 250, we have a current equal to 100 ampere. So from here we can solve for our IA. Of course this will be equal to ISH, which is equal to 2.5 plus IL, which is equal to 100. So IA will be equal to 102.5 ampere. Okay, so we have our IA, which is equal to 102.5. Next is to solve for our EG, right? Okay, so from that we can solve for our EG by taking KVL. at this mesh. So KVL at mesh 1, so we have KVL at mesh 1 will have negative EG plus VA, or the voltage that is voltage drop of the armature conductors, plus VSH. But it is further mentioned that our VSH is equal to our VT. So our VA is of course equal to IA multiplied by RA, which is equal to 102.5 multiplied by RA, which is equal to 0.06. So 0.06. So therefore we'll have a value equal to 102.5 multiplied by 0.06, in which this is equal to 6.15 volts. So substitute natin dyan, then we'll substitute that there, and then we'll substitute our VT, which is equal to 250. So therefore we have 6.15 plus 250. So therefore our EG will be equal to 256.15 volts. Next, the power therefore in the armature is equal to EG multiplied by my IA, which is equal to 256.15 multiplied by our IA, which is equal to 102.5. So this will be equal to 256.15 multiplied by 102.5. So it will yield to 26,255.375 watts, or it is equal to 26.255 kilowatts. Okay, next is when the motor is acting as a motor. Okay, so when the machine is acting as a motor machine, so therefore you'll have your EB, same diagram. So you have our EB, and then you have our RSH, and then of course we have our terminal voltage. Okay, but in this case we will supply power to the motor in order for the motor to generate mechanical power. Okay, so from here will have a current that would enter to the motor. Okay, so the current that is your IL is, of course, since that is your full load current and your terminal voltage and your power, input power, so therefore your 25 kilowatt will be your input power. Okay, in that case your IL will be equal to your IN, which is equal to 25 kilowatt divided by 250, in which this is equal to 100 ampere. So IN will be equal to 100 ampere. Then of course we have our ISH, since it is all the values in your field circuits are equal, so therefore this is still equal to 2.5 ampere. And then now we have our IA, in which we will supply the armature circuit. So from here our IA will be equal to IL or IN minus ISH, right? So from here my IN is equal to 100 minus my ISH, which is equal to 2.5. So therefore we'll have 100 minus 2.5, we'll have a value equal to 97.5 ampere. Now next is would take KCL at EG, take note of the current direction. So therefore we'll reverse this, diba? So we have positive negative VA and then positive negative VT. So we'll have EB is equal to VT minus VA. Okay, so in this case your VA will be equal to IARA, which is equal to 97.5 multiplied by your RA, which is equal to 0.06. So 97.5 multiplied by 0.06, which will yield to 5.85 volts. So 5.85 volts, and then we have our VT, which is equal to 250, right? 250 minus 5.85, your EB will be equal to, so 250 minus 5.85, okay, your EB will be equal to 244.15 volts. So therefore, the power generated in your armature at motor is that this will be lower than the input. Okay, how about in your generator, the power that is generated in your armature is greater than your output. Okay, so therefore your EPA will be equal to EB multiplied by IA, which is equal to 244.15 volts multiplied by your IA, which is equal to 97.5 ampere. So therefore we'll have 244.15 multiplied by 97.5, which is equal to 23,804.62 watts, or simply 23.804 or 05 kilowatts. Okay, so that would be your PA. That is for motor, this is for generator. Okay, so as you observe, the current direction will change, especially for your I in, IL, and your IL, ISH. Okay.